Okay, demo. All right, I've got a case study for you. There is a fuel gas knockout drum, and my SIF reference for it is SIF number 62. If you're interested to know why, I can show you, but you're probably not. But what happens in the knockout drum is that it should be protected against the high pressure in case that the inlet pressure controllers fail. So these are the inlet pressure controllers. The main gas inlet is from there. As you see, there are some shutdown valves on it. There's MEG coming in, and some product separators send stuff through to this fuel gas drum as well. The pressure is regulated and controlled by these two valves. I think the pressure signal is about here. It's not in the picture here. And that is the pressure signal that is meant to be protecting the knockout drum. Outlets, there's one drain and outlet to the flare, and of course the valve that sends stuff down to the compressors and other places within the plant. Okay, so now let's consider a case where my SIF is designed as this. When the pressure is high, I'd like you to go ahead and, as a primary action, close all those valves. All right, so these are my primary actions in case of high pressure on the inlet. High pressure on the inlet is normally an indication of PIC failure. Okay, but if I go and study the cause and effects for this particular safety function, I see that there are secondary elements to it. So cause and effect also tells me that those three valves should also be shut down. The SRS, however, the SIF is this, just the orange one. There are secondary elements, and then of course there is like an interlocking function that is programmed within the DCS and says in these kind of cases shut those PCVs manually, which means put the PIC to manual, 0% output, shut them until we reset the trip. So that's the story of our knockout drum. Like I mentioned, only the orange ones are part of my SRS. The secondary ones are part of my cause and effect, and the blue one is a DCS function. It is important, and one of the key takeaways from this presentation should be also this. It is important to remember that SFM application is a SIF monitoring tool and not a cause and effect monitoring tool and not a DCS monitoring tool. All right, in this particular example, on 11th of November 1555, we actually had a pressure controller failure, and that caused my KO drum to go to 32 bar, 30 to 35 bar. The trip level is 32. All right, let's not forget what we want to do. All right, this is the SCR page, X Quantum SCR. This is basically your sequence of events recorder. And as you see, it's picking up events, safety events, DCS events, mode change events, what operator is doing, process alarm, whatever. And it's reading from more than one OPC server. One of them is the SOE OPC server directly linked to safety system, to the SCSs, and one is the XOPC, which is on network. So you see that a lot of these things have been just picked up. Yeah, but not all of them is what I want. So I need to be able to automatically filter them and pass them on to SFM, as I said earlier. I've highlighted the events that are of our interest, and then we go and see what SFM does with them. Okay, 1555.05, that's where my pressure goes high and then becomes high. At that point, safety system picks that high and then orders 1, 2, 3, 4, 5, 6 valves to close. These are basically the output of the SCS controller itself. They become false, means that those valves need to be closed. DCS is now, as you see, is showing on the faceplate that the valves are going to trip. On top of that, DCS is tripping all the PICs, so it's closing all those PCVs at the same time. Now here's the cheating part, because this was a simulation, and I had put the DCS on test function. So it means when the valves tripped, I had to manually give them feedback. So you see that the test user is actually closing the valve at that point manually. Yeah. So each one of my SDVs are now becoming officially closed. So SFM should now pick up the event of closing my valves as the completion of the SIF. And of course, some time later, I was happy with my testing and put everything back to recovery. So that's just a quick narrative of what happens. We've seen the primary and secondary valves going, 6 of them, and then PICs. Okay, going to SFM now. I've deliberately filtered it for that period of time so we don't see a lot of events happening. Okay, so this is my SIF overview that we talked about earlier on. These are all of the tab options that we have. You probably immediately see a traffic light system here that with a time and date on it. This is for checking the health of the SFM application itself. It tells you when it was last updated and if it's healthy or not, so that's fine. I haven't refreshed this page, but if I refreshed it, it would go to a minute ago. I don't want to do that because I don't want to miss my lose my filters. Okay, so it's showing me that I've had 4 SIF activations within that period of time. One of them is probably what we are looking for. If I clicked on any of them, it would bring me down to SIF activation here. Okay, so for the one that we are interested in is this one. This one is the fuel gas knockout drum protection. It's gone high at that point, 15:55:05. It has failed, and because I did a verification on it before, it has given me a green light for verification. Okay, so if I did click on that view, it would now take me to this view. First of all, what I need to mention here is that you don't see the pressure signal going here because I'm just rerunning a historical event. I'm not connected to the actual exoquantum and OPC, so it's missing the analog signal, but it's recorded all of my valve activations together with the moment of trip. So if you hover on the top of each one of them, it will tell you what these things are. So at that time, SCS has ordered the fuel gas inlet to close, and then it's ordered that valve from another vessel to here to close, and then it waited. I think the rest of them are all on top of each other. And then you see each one of them coming back. 1, 2, 3, 4, 5, 6. Okay. In this particular example, like I said, we are monitoring not only the primary elements, but also the secondary elements in terms of the valve travel times. All right, so it is giving me valve travel times in this view. All of them are well past the design target. The reason for it was because I was manipulating the valve manually, and it took me time to go through every one of them. All right. Very quickly going through the reports. So I did talk to you about the reports. 3 types of reports that are very usually used is the SIF overall report, SIF input report, and SIF output report. What you wanted to see was this report. So for that particular PZT, if I go further down, yeah, these are all the instances of my PSD. These are the valves that are involved in that safety function. So if you see that the actual travel time was 32 and it was meant to be 10, you get a red line. For the valves that met that requirement, you get a green. So going back to my first report, this is the main report that, like I said, you can get it from the page, or you can have it automatically made and emailed to you or shared in a shared drive in the network. It provides you with a lot of filter inputs. I have deliberately made it only one day and deliberately focused only on that SIF that we tripped earlier on. So you see on that particular period of time, this is my plant hierarchy, where that SIF was, with what the actuating devices are on that on that SIF, how many times they've got actuated. That particular valve 100 only got actuated once because I forgot to do it once. I did this test twice, but I forgot to manipulate that valve manually. So it gave me, it was only activated once. All right, so, and on the top of that, it says the initiating cause was the actual demand on the SIF, was not a test. And the design frequency based on the PFD average is that per year. And my actual frequency was that much. There's no independent layer of protection for this, and there has been the total time required for the SIF and how much time it was not available due to a MOS or due to degradation or to fault. Fault is basically another word for IOP, if it was in IOP and knives were open. Okay, so that's the overall report for my SIF. Let's see what was happening in terms of the input of that SIF. I've highlighted it here so we can see what exactly happened. It says that this SIF was activated because of PZI003. So that's the initiating cause for it. I have deliberately not filtered it to my SIF because I wanted you to see the rest of them for a reason. It gives me the plant hierarchy, where about in the plant it is, and as you see, if I hover on the top, it becomes like a little finger. It means you can drill down to that specific part and see what AP29 was doing generally. It also tells you how many times you've got activated. So the other SIFs, for instance, you see 2 or 3 of them. Percent in MOS override. I didn't put any MOS on it, but if I did, for instance, on that one, you would see the period of percentage of that SIF being in override and how many times they put an override on. That's quite a good one. And then the output, I think we did mention it earlier on. One thing that is worth mentioning here in the output report is not only the status, which is failed or basically met the requirement, you see the type of output activation in here as well. It is, as we speak, SIF. It could be, like I said, a partial stroke testing, or it could be a manual activation. So if I, for instance, go on the 12th and run that report again, you'll see that some of my SIFs got manually activated. And here, that is a pump. I stopped that pump, which is a part of a SIF, manually. So it's now telling me that you have manually stopped a pump, final element within a SIF. There's one last report that I didn't run through, and that is inhibits and override reports. Inhibits and overrides are also quite important, and because we're coming to the end of the demo, it will connect us quite well with the OSA. Let me show you what you get. Maybe if I make it one day, it would be better. It would take it some time to go and interrogate the SQL server, but I can, yeah, there. So for each one of the SIFs, you should design or consider a condition for the SIF, which could be in a MOS override, or it could be a failure mode when you have the IOP, or degrade if you have a voter. And then of course things would go back to normal. SFM would give you a proper time duration for each one of your MOSes, or the time in failure if there is a maintenance going on. And this is just simply static override monitoring. It would be different from what OSA does, which is dynamic override monitoring. I have only some key takeaways from the SFM. So we did mention that it's a SIF monitoring tool, not cause and effect. However, there is nothing stopping you from putting extra elements into it for specific monitoring purposes. Like you've seen, I've put, instead of 3, 6 valves in my SIF, but it's not a SIF function. He's not specifically a SIF. It's just monitoring. It needs SCR, as you saw in the presentation. So it needs a server that has both SCR and SFM to be able to work. You did see that it is capable of connecting to more than one OPC server. So in case, for instance, we have even had cases where the safety events came from a third-party PLC like HEMA. That is also a possibility, but it would take a little bit more work to get those alarm and events into SFM. Can be virtualized, as we just saw, and it can be deployed within the Active Directory environment. If you, for instance, have a PCN system that is not just the flat network and your IT system is a domain, it can become a member of the domain. Automatic reports, I repeated about the automatic reports in the form of an email or file share. So that's another one that is quite important. A lot of my clients are getting automatic reports based on a predefined schedule, maybe monthly, weekly, or whatever. So we can define that schedule for you if you needed it. And web-based real-time application. It means that if you know what you're doing, you can put the port number of that website onto your planned firewall and make that web page accessible through the offices. So you can access the SFM pages from the smart room, for instance. And I have clients who sit in their corporate offices and get SFM pages all the way from a platform in the middle of North Sea. Yeah, I implicitly mentioned that we can use non-Yokogawa safety systems as well, but like I said, it needs a little bit more work because not all of the alarm and event messages are similar to what SFM determines and detects, but it can be translated.